How we doing today, Khadija? I hope you're doing good. And get ready here. Put up myself on the main screen. There we go. Hey ho, hello, hello, hello. How we doing today? How we doing today? Coco just woke up like a half hour ago. Good. Glad to see that you are awake. Doing good? Excelente. Excelente. It's been already been a pretty decent day. So I got up pretty late, but I should be good to go today regardless of that fact. These glasses on. Alright, there we go. A little scuffed. There we go. What's going on today, Khadija? What you gonna be up to? Besides math, of course. Mathematics, to be like, oh, okay, yeah. Yeah, no, it's alright. Grab some examples here. There we go. Good to go. And to grab some examples there. I'm going to try to do homework. I've been logging in, staring at the screen. You gotta. I told you before. You gotta put in the work and the effort there, Khadija. This is on you. I know adulting is tough, but you gotta do it. Yeah, look, I want you to succeed as much as I. Look, I'm just gonna put it this way. Promises are fine if they're kept. Show me action, and I will certainly praise you for doing so. Actions speak louder than words, Khadija. I'm just gonna point that out there. All right, fine. I'll believe you, but again, you gotta show me. Like everybody, a promise isn't an intent; it's a commitment. I'm gonna actually defer on that. A promise is words to me, but when a person shows me consistent action, that's when I will believe in the promise that they gave me. Because see, anybody can tell me words, like anybody can tell me words, but it's really the actions, and assuming that the consistent actions will reflect the words that they have chosen, then will be that will be when I actually believe said person. So that's adulting 101. Hunter, how you doing this absolutely fine morning/afternoon? Feeling a little more focused? Okay. Hopefully things work out. I'm comfortable with the fact that things can easily work out. Like I got no problem with that. Feeling mathy, I respect that. I mean, like I said, people tell me lots of things. It's all a matter of show me the money. Show me the money. Kind of important. Just show me that money. Gotta show me. Same, I get lied to for a living. Yeah, you work for the city. Yeah. Good afternoon, Brian. If you work for the city, it's a complete lie all the time. But I didn't, but I didn't park there. Oh, okay. Okay. My car's not sitting right there, okay? In a no parking zone. I don't deserve a ticket. Come on, man. Just because I don't have a permit to park here in this said neighborhood doesn't mean I deserve a $100 ticket. Like, okay. Just because I left one of my 6 cars in and around this neighborhood doesn't mean I should get 4 of them towed. Just because I don't have tags on my vehicles doesn't mean I should get a ticket and tow or the boot. I don't know what department you work for. I find all the tags and stickers needed for a car is stupid. Well, you're gonna need tags and stickers just because that's how you make money. Let's not lie about it. It's how you make money. That's how you make sure that everything is up to date. Of course it is, but you gotta pay. Look, you gotta pay to play. That's how it works. Don't forget, driving is a privilege, is not a right. So having a car is an extra privilege, is not a right. Spend $150 on a city sticker, yucko. What department you work for, Brian? If you work for the city, I don't know which department you actually work for, so. I'm just really curious. Right? I believe you said law enforcement, right? I think you said law enforcement, but I don't know what kind of law enforcement you do. Like, specifically. Like, if you're part of a specific division, Brian. But if you don't want to say, then I understand. I remember him telling me it was like law enforcement, but it's like, I don't know if there's a particular department that he's in. You work citywide? Okay. You just work the beat then, I guess. Is that be accurate? Or if you work in like every neighborhood. No, I'm everywhere. Okay. Okay. So anywhere where there's a call, you're gonna go and respond and stuff like that. You're always on call. Every neighborhood. All right. Every neighborhood. So basically, in Brian's case, he's literally seen everything. Like, if you've been to every neighborhood, then yeah, you've literally seen everything that the city has to offer, both the good and the bad. No 2 neighborhoods are the same in this city, so. It's almost like when my friend from New York City told me, like, hey, if you just walk down 1 block in New York City, he's like, walk 1 block and you'll notice that it's a completely different atmosphere than if you walk the next block over. And so we did. We walked 1 block over from where he was living in Harlem. And yeah, it was like a completely different atmosphere, completely different everything. It's like every single block had their own little microcosm, like the mini city in it. It's really super fascinating. Super fascinating. Because it's like he moved from Harlem to Queens, so I saw his new place in Queens, right? Yeah, I saw his new place in Queens, and so he's like, we walked down the street. We walked down the street from his place in Queens down to a 7-Eleven on the corner, and that's effectively where everything kind of converged. It kind of stopped, and then everything just kind of changes. Once they hit the 7-Eleven, it's remarkable, completely remarkable. Hey, Gomesh, how you doing? Hopefully doing well. Nicholas, good morning / afternoon to you. Hopefully you're doing fantastic. Good to see you. Hopefully doing fantastic. Yeah, it's super neat. Like when I was living in Tokyo, it wasn't Tokyo is a little different than that of like maybe bigger cities here. Tokyo is split up into wards. Each ward is different in Tokyo, because there's 23 wards in Tokyo. But each like a mini, each having the population of a big city here. Like literally, you can fit like big city populations in each ward of Tokyo. That's how ridiculously big or ridiculously packed it is. But it's yeah, they're different in their own regard. See if I have a let me see if I have a picture. There's a good picture that was online reflecting the population of Tokyo compared to like big cities in the United States. It's weird how they look at population. Like how they look at population is very very unique and very different because uh how long did I live in Tokyo for? 3 years. 3 years. So I'm gonna bring up a little map here, and then you'll understand exactly how crazy this is. Hey Jess, morning slash afternoon to ya. Let me show you this right here. So this is what you can literally fit into Tokyo in terms of the similar populations in their 23 wards of Tokyo. Um, was I teaching in Tokyo? Yes, I was teaching English in Tokyo. That's what I did for 3 years there. I lived 1 year up north in Hokkaido before I moved down to Tokyo, actually. So literally, you could fit like populations of giant cities inside Tokyo. That's how densely packed it can be. And you have all these little alleyways, and you have all these little things going on in Tokyo. I applied to teach English in either Hokkaido or near Kyoto, but I was rejected. Oh, that sucks. Yeah, I applied to a couple places. This is a long time ago. I applied to a company that then folded, then was reborn from the ashes. That was a disaster and another story for another time. That was a crazy story. But you can see here, like you can literally fit the entirety of Chicago, all the population of Chicago in one small ward of Tokyo. Like literally. You can fit all of New York City in one ward of Tokyo. It's not. It's dead serious. Good morning slash afternoon, Lysaidana. How are you doing? Hopefully doing fantastic. I know what Aikido is. I've never heard of Aikido-jitsu. I'm assuming that's another form of martial art or sword martial art, like Aikido, like martial art. So. Yeah, so things are pretty densely packed. No lie. Oh, Aikido was derived from it. Okay. Yeah, so it's a nice area to live in. Not surprising, Japan is fanatical about not. There's not a lot of space though in Japan. So let's get one thing straight. The amount of space in Japan, there isn't a lot of space in Japan. All right. Much of it is mountainous and is extremely hard, or if not impossible, to build on. So the amount of flat land in Japan is basically, yeah, there's basically a very limited amount. So housing is crazy expensive in Tokyo if you want to own something in Tokyo. I mean, yeah, housing is pretty expensive, but most people rent anyway. So, you know, most people rent, and rent can be crazy. I guess I could talk about rent. Rent is a little bit nuts, all right? So let me put it into perspective here. You have to pay, when you talk about renting an apartment, and even if you're a foreigner or a Japanese person, regardless, okay? The issue with it is that you have to pay what's called key money. And key money is basically the same thing as what we do here when we talk about, when you first get an apartment here, you have to pay like a month's deposit, right? You say, okay, well, the rent on your apartment here is like 1,200 bucks, for example, whatever. And you give them like $1,200 in advancement. That's your deposit, right? That you can get back after you move out. All right. So that's perfectly fine. However, in Japan, instead of paying 1 month's deposit, you pay 6 months deposit of key money. So if the apartment is literally like 1,200 bucks, you have to pay 7,200 out of your pocket before you even walk in the door of a key money. It's really nuts. 500 a month for a garage, that's true. That's very true, Ulo. It is 500 a month for a garage, but that's why you don't drive. Watch House Hunters International in Tokyo? Yeah, look, in all honesty, one thing that I do appreciate about Tokyo, if there was one thing I did appreciate about living in Tokyo, is that one thing it forces you to do is because you don't have a lot of space, okay? Because you don't have a lot of space, it does force you to save money because you don't have a lot of space to buy unnecessary junk. All right? When you think about it that way, you're like, okay, you're not going out buying unnecessary things. You're actually going out and actually buying things that you absolutely need. So it's really important to understand that, yeah, it does force you into that situation, and it's not a bad thing. It makes Tokyo a lot more livable than what you think it is. So I would say that you're not going crazy with the amount of space, so you don't have to go crazy with the amount of things that you buy. Um, Most of the time, you're going to spend money on food, and well, if you're part of work, then alcohol. So, but if you're not a drinker, then you'll probably go spend more money on food. Tokyo is clean, yes. Neighborhoods do like to keep themselves clean. And also, one other thing is that where I lived in the manufacturing district of Tokyo. So let's see if I can find it here. I lived in one of the manufacturing districts of Tokyo, which is called Nishinipori. That's where I lived. It's right around this area. And Nishinipori is a really nice place. I mean, it's got fabrics, it's got manufacturing, it's got pretty much everything. It's close to the Arakawa River, where I lived anyway. It was pretty close to that. I was like a kilometer or two away from the station, so it wasn't like too crazy. And yeah, even we had a bunch of stray cats in and around the neighborhoods, and they serve their purpose too, by the way. Stray cats certainly keep a lot of rodents away, so it was very rare that we saw rodents around because most of the stray cats would take care of pretty much everything. So people would feed the stray cats, and then the stray cats would effectively take care of the rodent issue in and around the neighborhood. So it was like a good symbiotic relationship that everybody had. So my favorite part of walking in the morning to work was when I go to the train station was watching one of the locals literally ride on his bike and walk his Great Dane. That was pretty funny. It's like this Japanese guy, the Great Dane, is almost as tall as him in the bike, and he's like riding the bike, and the Great Dane is walking around. It was really cool. What school did I teach in? I taught in a school at the time. I taught in a school called GABA, so it was like a purely English language school. So it wasn't like an elementary school or nothing like that. So, What was your favorite city in Japan? Um, wow, I've been to several cities. My favorite city by far and away, I think, still has to be the first city I lived in, and that was Asahikawa. Asahikawa is like a sleepy town, but it's super chill and super comfortable. The city of 400,000 people, which is considered small in Japanese terms. But it's like a good mountain town, has pretty refreshing air. It's the only town that I'll actually accept the winter in, to be perfectly honest. Um, I lived there for a year. It was great. I had a wonderful time in Asahikawa. It's a small town up in, not really small town. It's the second biggest city in Hokkaido. So Sapporo being the biggest, and then Asahikawa being the second biggest. And there's a lot of things to do in and around Asahikawa. So, or if you just want to sit and chill and relax like I do, and be the hermit that I like to be, then certainly it's the town to be in. So, yeah, I have some good friends. I have a couple good friends that live there still. So, you know, pretty legit. Sapporo, go get it straight from the tap. Yeah, if you go to the beer factory, you can. They'll actually give it to you. That's what it's about. All right. Oh man, I've begun 10 minutes already. Okay, I need to do intros here. What's the one thing I did in Japan that you wish we did in the US? There are several answers to that, but I think if there's one thing that I wish we did here in Japan was convenience stores. Like convenience stores over there are so like literally the word convenience in convenience store actually means the word convenience. Okay, so like it's not something that's taken lightly. You actually can do a lot at the convenience store in Japan. So you're like saying, "Oh, you want to get packages delivered? You can go to the convenience store and drop off your packages to be delivered. Oh, you want to pay your your national health insurance bill? You could do that at the convenience store. That's certainly possible. Oh, you want some semi-fresh food that you can nuke in the microwave? You know, that's not like gas station burrito-esque, like it's pretty decent. Yeah, you could get it at the convenience store. You know, you want actually decent quality food? Yeah, you get it from the convenience store, not whatever, you know, pre-processed crap that we get here at a gas station. So, we had more convenience stores, it would be like, it would be super convenient. It would be super good, like legit super good. You could do banking at a You could do banking at a not just ATMs. You can actually do you could do the ATM banking actually from a 7-Eleven. So 7-Eleven has their own bank in Japan. For those who don't know, 7-Eleven's actually much bigger than you think. So, and yes, 7-Eleven is a Japanese company. Before anyone asks. All right. Okay, I gotta get going here with this stuff. Let me go and do some intros, ladies and gentlemen. Let's go and do some intros, and let's get started with some math. All right, let's do this. All right, let's get going here. Okay, let's get started today. Welcome back to Tuesday. All right, so we're gonna pick up where we left off last time. Last time, ladies and gentlemen, we talked about logarithmic properties. We talked about expanding and compressing logarithmic equations. Okay. So today we're going to move on here to exponential and logarithmic equations using those same log properties that we discussed here yesterday. Okay, so that is what is on the docket here for today. To answer your question there, Lysandra, have you ever traveled internationally anywhere else? The answer is yes. From Japan, I traveled to Korea for a weekend to watch a StarCraft match. I've traveled to Pakistan before. That was pretty good. Though I haven't been to Pakistan since 1992. And the story about why I had to go to Pakistan is already crazy enough. So, yeah, that's a story for another time. I can guarantee you there's stories that would blow your mind. It's just, even that story about why I went to Pakistan just blows my mind. Okay. Alright, alright, but we gotta get going here with this new stuff that we have to do. Let's Alrighty. So let's go ahead and talk about exponential and logarithmic equations. That's what we're going to be focusing on here today, and that's what we're going to be doing. Easy. StarCraft, yes. OG StarCraft Brood War, when they still had the Pro League back in the day in 2008. Yes. I loved watching StarCraft. I love watching StarCraft 2 now. I just got, I got back into it again. And it's just like, it's so amazing. Forgotten? Goodness, no. It is definitely not forgotten. There is still a rabid fan base for StarCraft. It is the granddaddy of all granddaddy esports, and it is still quintessentially one of the best esports that you can find. All right. So let's go ahead and go to question number 1 here. Question 1 says, what rules should you remember into solving exponential and logarithmic equations? Okay, so for exponentials, use exponential rules, which we've talked about before here. Take the natural log of both sides, or use substitution to solve for these equations. For log equations, we're going to remember all the log properties we did from the last section there, and we try to compress the equation down into a if a log equation. So basically, we try to compress it down into one log equation, just like we did yesterday. So we're going to see a lot of examples of each of these today. All right, we're going to see what we're working with here. So let's take a good look here at some of these examples, and we'll see what happens. Okay. All right. Let's go to the big board here. Look at this right away. All right. So we'll start off with something easy, and then we'll work our way up. All right. So let's start off with something super simple. All right. Okay. So here we have 5 to the x power is equal to 125. Okay. So can anybody tell me here, 5 to what power is equal to 125? What's that going to be here? Five to what power is equal to 5 to the third power? That's correct. Now, that's very simple. I think people can easily see that. No problem. 3, says Joseph in the long way. I respect that, Joseph. All right. All right. But here's something else I want to show you. Even if this is a simple problem here, one of the other things that I can show you here that will be important for what we want to do is remember that we can also write it like this, right? We can write 125 as 5 to the third power, and we have 5 to the x power on the left-hand side. So in effect, if you want to actually get here, if you want to get x is equal to 3, you can set these exponents literally equal to each other, okay? You can set these exponents equal to each other if they have the same base. So that's one thing that I do want to take to the bank here, is that as simple as this problem is, all right, no question, all right? If you have the same base, then set the exponents equal. All right, easy. All right, now let's try another one. All right, so 3 to the 2x minus 1 is equal to 27. All right, so how can I start this problem here? What should I do first? Well, sounds like a plan. Again, think about how I did the last problem there, just kind of rewriting stuff. How can I rewrite 27 with a base 3? So think about it this way. 3 to what power is 27? 3 to the third power. That's right, Khadija. All right, good. So this is 3 to the third power here, and we have 3 to the 2x minus 1. Okay, so with 3 to the third power, all right, and we have 3 to the 2x minus 1, we're just going to set 2x minus 1 is equal to 3. And then we're going to go ahead and solve for x. So we'll just do some simple algebra here. Alright, that's 2x is equal to 4, divided by 2 on both sides. So here we get x is equal to 2. I probably should do it that way. Okay, so that's our final answer for that one. X is equal to 2. There we go. Alright. So you can see there, not so bad. Again, if we have the same base there, we're in good shape. Let's look at another one here. Alright, let's look at another one here. Which one is pretty? Yes, that one's actually pretty deep. Alright. A few tricky ones here that you can have to be very careful about, so. Okay, 4 to the 2x minus 1 is equal to 64. Ah, yes, question. Go ahead, Blink. Go ahead, my friend. Absolutely. Ask away, my friend. While Blink types up his question here, think about the base that you can use here to solve for x here in this case. Or the third. Oh, I guess I should have done that one. It's kind of a repeat. Why don't we try and make that 3 as well? Why are we solving for x? Are you talking about here to be are you talking about here? Are you talking about the left-hand side, the 2x minus 1, right? Yeah, okay. That's effectively what you're doing. So you're doing exactly that, Blink. Like basically another way you could think about it, a crude way you could think about it is like just cancel out the 3's, for example. And you're like, okay, you know, a crude way you could say, all right, you know what? I got in the same base. I can cancel out the 3's. I have 2x minus 1 is equal to 3. And so effectively you are trying to make it equal to 3. Right? Because you're setting those exponents equal to each other. Alright? So, in fact, to your question, you are effectively trying to do that. Okay? There's no question about that. Okay? So, on the basis of your thinking there, Blink, you are directly on the correct track. I guess this is what did we get here? We get 2 again? Okay. I need to come up with a different one. Alright, let me come up with a different one. This one was the same thing. Alright. I think I know which one I want to pick. Alright, not that one. I'll pick that. Okay. Let's go with, Alright, let's go with this one. 27 to the 3x minus 2 is equal to 81. Okay. So, remember what's the trick behind this? The trick behind this is to put it in the same exponential base. What would be the same exponential base here in this case? All right. Good. The fundamentals kind of 101 here, just trying to get things down. All right, so how can I rewrite 27 again? How does that go? How do I rewrite 27 again? 3 to the third power, that's correct, Nicholas. All right, so the way we're going to write this out, because that is 27, there's 3 to the third power. Okay, so the way we write this out is 3 to the third, and then on the outside, because that's 27, it'll have the 3x minus 2 here on the outside. Okay, we'll show exactly what we're going to do there algebraically in just a moment. But we also need to express 81 as 3 to some power. Okay, Khadija, that's correct. 3 to the 4th power here. So let's take a look at what happens here in this case. Okay, in this case, imagine if these base 3's were gone, and I'm just going to set the exponents equal to this. So we have 3 times 3x minus 2 equals 4. All right, and I'm just going to go ahead and proceed to do the same thing here. And let's see what happens here. So here we get 9x minus 6 equals 4. All right, we'll go ahead and add 6 to both sides. So you get 9x is equal to 10. And finally, we'll divide by 9 on both sides. So our final answer here is x is equal to 10 over 9. All right. So that's our final answer there for x in that instance. All right. GG. GG no re. Okay. Let me layeth the smacketh down on your candy asses. Okay. An old reference. That's an old Rock reference. If you watch the WWE during the Attitude Era, that is what he would used to say during promos and stuff. He just quoted the Rock. The Rock would always say, "Let me layeth the smacketh down on your candy asses." I used to watch WWE all the time back in the Attitude Era. It was the best, man. The Attitude Era was so amazing. I now watch AEW wrestling, so that's what I do. Actually, I'm wearing an AEW shirt, so that's what you see if I stand up here for just a second. I'm wearing John Moxley's shirt here. If I back up a little bit on the camera, there you go. So there's John Moxley's shirt. It's pretty cool. I like it. It's fun. So there you go. Good stuff. No thanks. John Moxley, bruh. Indeed, John Moxley. John Moxley is 10 times the wrestler that Dean Ambrose was. Dean Ambrose, the character, was good with the Shield. John Moxley, the singles wrestler, there you go, even better. Darby Allin, there you go, that's a G. Darby Allin is a G, man. Holy cow. I will give it up to Roman Reigns, though. Roman Reigns is really good. Like, he was bad at first, like, because they booked him really bad, but he's gotten a lot better. Like, Roman Reigns now, the actual wrestler, and the storyline with him being, like, the head of the table and stuff, that's actually pretty good. I ain't gonna lie. I do like that storyline. Because Paul Heyman is really good, so. Let me tell you, Darby could take hits. Oh my god, Darby takes bumps, man. Thrown down a flight of stairs. He's got the coffin match coming up. Does the coffin drop. You know, he had the cinematic match with Sting. Like, holy smokes, man. That guy takes bumps like crazy. Yeah, I don't know how you not put Darby over even more. All right. Anyway, I gotta do another one here. Yeah, let's do that one. All right. So how about this one here? How about this one here? You stopped watching when Stone Cold Steve Austin was the man? Fair enough. Stone Cold is still amazing. Hunter, you can't give the answers away, bro. Alright, so the answer here is 2. We have a base 2 here. So 2 to what power? I know, but I gotta have him discover it too. Like, it's important. Like, one of the things I stress myself on is getting them fundamentals down. Getting them fundamentals is 101. Because if we don't understand the fundamentals, then getting any other of the advanced problems is going to be a collective nightmare. This I know from experience. Alright, so 2 to what power here is equal to 8? 2 to what power here is equal to 8? Yokaimashita. 2 to the 3rd power, good. 2 to the 3rd power is equal to 8. And how about 16? 2 to what power is equal to 16? Two to the 4th. Okay, good. All right, so now we're just going to set these exponents equal to each other. 3. Okay, so here we get 6x plus 9 equals 4x minus 1. Let's go ahead and see what we get here. Subtract by 4x on both sides. Subtract 9 on both sides. Yeah, 2x is equal to minus 10. Divide by 2. So here we get negative 5. Okay, so x is equal to negative 5 here. No problemo. Oh, did I miss that? What did I miss? No? Hang on a second. Go back. What did I miss, Hunter? Hang on a sec. That should be, hang on. Oh, that should be 4. Oh yeah, you're right. You are correct, sir. That is indeed 4. You are correct. Yeah, I just had to distribute the 4. I totally forgot. Thank you for pointing that out. If I make a mistake there, yeah, that's fine. You can point that out to me. 100%. I'm a dum-dum, so I need to be corrected about dumb things. Alright, thank you for pointing that out. So here we get negative 13 over 2. Okay, there we go. Alright. Alright. That's perfectly acceptable. You're like, you made a mistake! You'd be like, yeah. I don't disagree with that. Alright, so I'm gonna do one more here for the exponent, these simple exponent ones. I just want to showcase one more type of problem here. And then we'll do the more advanced exponent ones. Okay. Alright. Yeah, the answer was much prettier, though. Being pretty doesn't mean it's correct. Alright, e to the x plus 4 is equal to 1 over e to the 2x. Okay, so in this particular case, if you run into a situation that looks like this, all right, the trick for this is to just rewrite that right-hand side. All right, that e to the 2x. So can you guys tell me here how would I rewrite 1 over e to the 2x? I know Hunter knows, but we'll see if you guys can get this here. So How can I rewrite 1 over e to the 2x here? How does that work? If I had this, by the way, let me point this out here. If I had 1 over 3 squared, okay, I can rewrite that as 3 to the minus 2 power. Again, I can move that to the numerator and just flip the sign of the exponent. All right, there you go, Khadija. That's right. So by the same exact premise, by moving it to the numerator, to make this significantly easier for us to use, we're going to have e to the minus 2x here instead. Okay, so we can move it from denominator to numerator with the caveat that we have to just flip the sign of the exponent. And now we proceed with the rest of the problem just as normal. Set the exponents equal to each other, and then go ahead and solve. So let's see what we get here. Subtract x. 4 is equal to negative 3x divided by negative 3. All right, and that's going to be our answer. X is equal to negative 4/3. Okay, good stuff. All right, questions so far. Got many more examples to do here, but because there's a lot of different types of these examples, then we're going to comprehensively cover each one. So, yeah, that's pretty much how it has to be. No questions? Okay. Okay, now, let's go over the next type of question here. So far we've looked at some examples here that basically have said, okay, well, we found the same base here, and then we went ahead and put it together, okay? And we went ahead and we said, all right, you know what? Yeah, you set the exponents equal to each other, and then that's all well and good. However, the next case may be a little bit tougher to use. So let's take a look at the next example here. Let's met it out. Let's start off with something simple, and then we'll work our way up. Okay, let's go 19 to the x power here is equal to 147. Okay, now, there is an issue with this question. This question would say, if we were to actually solve for this, well, I would need to figure out 19 to what power is essentially 147. If I could rewrite that, that would be easy. Unfortunately, it's not as easy as it sounds. If you tried it on a calculator, for example, if you said, hey, try 19 squared, that's not going to come out to be 147, not even close, okay? So you need to be able to find this in a different way. Okay, so we can't put it in the same base like we did in the previous examples. So we're kind of out of luck on that front there. All right. So the key is, what's the key here into doing problems like these where you cannot match the bases of the exponents together necessarily? There definitely is a trick, and this trick here comes from what we actually had discussed here yesterday. Okay. So the trick here specifically is to take the natural log of both sides. That's the trick here for this particular problem. We're going to take the natural log of both sides. All right, so this one here is not so easy to see when you first look at it. Now you're probably saying, well, hold up a second. You take the natural log of both sides. What exactly does that even do? Like, okay, you take the natural log. All right. So just to rewrite this one more time. So the real question is, what can I do starting from here? What happens at this juncture here? If you remember, we talked about the 3 rules last time, right? We talked about the product rule, the quotient rule, and then finally the last rule that we talked about there was the power rule. Okay, remember when we deal with logs, and in this case here, natural logs, um, we can go ahead and effectively move the exponent out to the left using the power rule that we had discussed here from last time. So we're going to bring that x there, we're going to bring that out to the left here. So essentially this is what we have. We have x times natural log of 19 equals natural log of 147. Okay, so this is what we have here based on the properties of natural logs. Okay, so just put a little note here. Okay, note, we use the power rule here of logs. Okay, all right, so we have that. That's perfectly fine. All right, now, can anybody tell me here, how would I solve for x at this juncture? Because these first two steps, admittingly, would be a little tough to see if you've never seen them for the first time. So that's fine. I give a pass for that. But how would I solve for x here in this instance? What would I do? What do you think I should do here if I'm going to solve for x? Subtract natural log of 19. That's a good guess, but that's not exactly what I have here in this case, Brian, because I have x times the natural log of 19. So I can't really subtract by the natural log of 19 because I'm not adding it. Divide by the natural log of 19. Now that is correct. So, right. So because we have multiplication with x, we're just going to do the opposite, and we're going to divide by that natural log of 19. We're going to divide by the natural log of 19 just like so. And so that's all we're going to want to put in our calculator here specifically. Okay, we're going to divide by that natural log of 19 to solve for x. So if we take a look here at our calculator, let's bust out our calculator here. All right, so I have natural log of, I'm going to go ahead and just do that over here. So natural log of 147, put that in parentheses, divided by natural log of 19. Be sure to put two separate natural logs here, by the way. All right, not just one. And then we're going to get a decimal answer here. Okay, so if you get a decimal answer, that's fine. So I'll go with 4 decimal places here. I'll go 1.6949. All right, so go ahead and move this over here for right now. So 1.6949 here. That's what we get here for our final answer. Okay. So that is, in effect, what we get for x. Okay. Any questions about that so far? Okay. Let's look at another example here. Let's see what we can do. All right. Okay, okay. All right, I gotta stop thinking. All right. Every time you write that Lysite run on no thank you, I think in my head, si de nada. That's what I think. That's what I'm thinking every time. I want to say it so bad. Oh man. All right. Let's do the let's do please do. All right, let's do the next one here. Okay. All right. So actually I'm going to combine a couple things here. So let's do 3. I wonder if I should do that one. Yeah, let's do that. That's fine. 2x plus 1 minus 5 equals 1,000. Okay. So let's go with this here first. Okay. All right, so this one here is a rather involved problem. Actually, you know what? I'm going to probably move that up here. So this one's going to require a little bit more than what I've written. Let me rewrite it here. All right, there we go. Okay. Okay, so let's talk about what we want to do first. What do you think I should do first in a problem like this? Well, sounds like a plan. Well, sounds like the first thing that probably be a good idea in order to make this a bit easier to do. Yeah, add 5 to both sides. All right, Brian. So the thing is that if we do natural log, we need to add 5 to both sides and then take your suggestion there. So you have the right idea in mind, but don't forget we have to add 5 first to both sides. Nah, you're not an idiot. Nah, dude, you're fine. Just gotta remember, just gotta go methodically, one step at a time, right? That's the idea. We just want to take it one step at a time. All right. So nothing to be ashamed about. It's just like, hey, just gotta take it slow. That's all. Well, don't call yourself an idiot. You're fine, my friend. Oh, that should not be 2. That should be 7. Look, I look, as a person who's failed a math class before, I totally understand. Okay, so I'm here to teach math. Hey, I got no problem with that. It's just, hey, I had to take it slow. I had to slow down. That was me back in the day. So math wasn't a natural thing for me. It was a slow process. It was the slowest of slowest grinds. Big LN guy over here. Now I'll take your suggestion here. I'll do the natural log here in this case of both sides. Let me put that in a different color. That in red. There we go. So I'll take the natural log of both sides as is suggested. Okie dokie. So now the question is, what should I do next? What should I do next in this process if I'm going to solve? My whole goal is to get to solve for x, right? That's my goal, right? So we can't forget about that. But uh, how exactly are we gonna get to that point here? What should I do next? I cannot divide by natural log of 3, and the reason is because I have an exponent there, right? I have 2x plus 1. So I can't just, unfortunately, I'm not allowed to magically divide by the base of an exponent. I can divide, now I can do that. I can do the power rule there. So I could move the 2x plus 1 in front of the natural log of 3. That is correct. All right. So that part I can do. Okay, that part I can definitely do. Now, at this stage of the game, there are 2 different ways to approach this particular problem, but I'll let you guys dictate what I should do here in order to solve for x. So, what should I do here first if I'm going to solve for x? Like I said, there's 2 different ways you can get to solve for x. One's a little more messier than the other, but they both work out to be the same answer regardless. What would we want to do here next? subtract 1. Don't distribute. Actually, distributing isn't bad in this case. Distributing is not bad in this case. It's actually much more manageable. Divide by natural log of 3 on both sides. So yeah, you could do that. That's fine. Yeah, so let's do that there. But distributing is the messy route, Hunter? I disagree. Distributing is the nicer route. I ain't gonna lie. Yeah. Somebody's got some biases. No, Jess. We do not want to divide by 2x plus 1. All right, that's the last thing we want to do. We want to get x by itself, so we need to take care of every roadblock in the way first. We could divide by natural log of 3. Remember, natural log of 3 is just a number. It's some gobbledygook decimal number. I don't really care what it is, but I can divide by it on both sides because it is just a gobbledygook number. I can do that. All right. If I divide by 2x plus 1, then I'm going to be in a bad way. All right, now we can proceed to do the rest of the problem here. Here we can subtract by 1 on both sides. So just treat it like a regular algebra problem. Remember that minus 1 here goes on both sides just like so. I guess, you know what, I should put that in a different color. Actually, that a little bit easier. Subtract 1 in purple, and then I'll subtract 1 in purple here. Okay. So let me expand this out a little bit more. Okay, so what I have here is I have 2x equals natural log of 10, 367 by natural log of 3 minus 1. And we divide everything by 2. We have all this divided by 2. All right, and so this is going to be our answer here. Now, if we want to get this as a decimal to work out appropriately, you're probably looking at this and you're like, "Woo, this looks pretty awful." I'd be like, "Yeah, I guess that's fair." So let's bust out the calculator here. I'll show you how to do something as even as ugly as this on the calculator. We'll take a look at this one. All right, so what I like to do here on the calculator, and this is actually good because I like to do this very often on the calculator, is I try not to overwhelm myself about what I enter into the calculator. If I enter everything in all at once, then usually it ends up to be a disaster. So I just like to take it one step at a time. So the first thing I look at is, okay, if I got to figure out what's in the parentheses here, I take natural log of 10,367, 67, please, divided by natural log of 3. Wow, Gemma, you're here early. Hey, how you doing? All right, so we get some random decimal here. There you go. We'll subtract by 1 that particular answer because we have minus 1. And then whatever we get for that gobbledygook answer, we'll just divide that by 2. So I just did it in 3 steps here. And I'm going to get it consistently because I'm just doing one step at a time. So 7082 is what we get here. Gemma, what's going on today? Doing good? Excelente. That's what I like to hear. That's what I definitely like to hear. I hear England's doing good. They're up 2-0 against Germany. You know, go to the round of 8. This could be Germany. This could be England's best showing in the Euros in a long time. All right. All right. So 3.7082 is what we get here for our final result. So again, just take it one step at a time here, and you should be just fine in that regard. Any questions about that? That's fair then. England won is full time. England won 2-0. Nice. I'm rooting for England because I got a lot of good friends like Gemma over in England. So 100%. If that's the next country I'm going to go to, then it's got to be England. I got to go visit my peeps out there. I got a lot of peeps to visit. It is going to be a whirlwind if I go out there for like a good 3 weeks to a month. Nope. All right. All right. Good beans. Good beans. All right. Good. Let's go ahead and do the next guy here. That's a It is a decent time. It's about 7 o'clock. Ain't nothing wrong with that. Nothing wrong with that at all. I see no issues. Okay. Yes, indeed. Thank you for the thumbs up. I appreciate that. All right. Next. After we're done with examples, yeah, it's gonna be a little bit with the examples here, the amount of examples that we have. All right, next one here. Let's look at this one here. Two. Oh, plus. All right, so this next one here is going to look a little confusing. All right. So this next one here is going to look a little confusing. 2 to the 2x plus 2 to the x minus 12 is equal to 0. Let's talk about how to do a problem like this. So this is like one of the other types here of the problem that we have to do. Then I got one more to do after this one for exponential, and then we'll move to logs. Okay, so what's the trick behind this? There is a trick behind this particular problem here, and I want to state that right away. The trick here is we're going to use substitution, okay? We're going to use what we call U substitution. It's your birthday in 26 days? Very nice. How old are we going to be, Gemma? 26 days from now, how old are you going to be? I know how old I'll be when it's what day? September 20th. Yeah, that's my birthday. All right. All right, so we're going to use U substitution. Now the question is that how are we going to define the letter U? Well, defining the letter U is whatever this middle term is. This middle term is what we're going to define U as here in this case. The big 18, heck yeah. That's what I'm talking about. I'll be the big, well, I don't know. Some people may know my age in the chat. I don't remember if I asked you guys if you guys know my age. I thought I did though. Anyway, U here is going to be equal to 2 to the x. You know, yeah, see? You know what I'm doing. So U here is equal to 2 to the x. If I have 2 to the 2x power here, all right, U squared is equal to 2 to the x squared, which is going to be 2 to the 2x. So if I went ahead and I rewrote this in 21 in August 2nd, very good. I'll be this age on this here. So there you go. U squared plus U minus 12 is equal to 0. So I'm just going to be using here this guy right here. All right. All right. So I have U squared plus U minus 12 is equal to 0. So what I'm going to do next here is I'm going to go ahead and factor, all right, in this particular instance, u squared plus u minus 12. This is what we want to actually end up with. So to factor here, we want two numbers that multiply to minus 12 and add up to 1. And that's going to be specifically 4 and negative 3. On the same birthday as your cousin? Hey, I can respect that. So here I have u plus 4 is equal to 0, and u minus 3 is equal to 0. So here I have u is equal to minus 4, and u is equal to positive 3. So because we have u here is equal to negative 4, and u is equal to negative 3, we're going to go ahead and replace u with 2 to the x. I'm not even doing this to be nice, but you legit don't look your age. You look like you're. I know people say that all the time. Like I asked my other class, and they said I look 30, and then I have to sit there and tell them I'm like, no, I'm gonna be 40. I'm 41. I'll be 42 this year. I'm like, I was 30 years old when I started working for the college. I was like 30, 31. Like that part is true. All right. So I have 2 to the x equals negative 4, and 2 to the x is equal to 3 because u is equal to both of those values. Now, one of the things you can take to the bank is 2 to the x equals negative 4 is not possible. Again, any exponential function can never be negative. So you can throw that one away because it's not even in the domain. There's no number for x that'll ever make that negative. So that's not going to happen. However, 2 to the x is equal to 3 is certainly possible here. And again, that's going to use the same technique we did in the last example, where we took the natural log of both sides. Unless the base is negative, but in this case here, the base will never be negative. So, since regardless of sign, we're going to take that middle term there. Aging like fine wine. I don't know what's a good wine. Uh, Moscato. Yeah, like a Moscato. I'm not a wine expert, so we're just gonna roll with that. We'll bring this X out here to the other side. Hey, Athena! There you go. My man's a whole cask. Athena, hello, hello. How are you doing? I hope you're doing fantastic. Apparently, Athena, I'm a whole cask of fine aged wine because I don't look my age. Apparently, so that's the bottom line. Because there you go. You doing Oh, good. That's a new. Yeah, it's a new one on me too. Apparently. Sad part is I'm not worth a lot of money, unlike a real aged fine wine. We're gonna divide by natural log of 2 on both sides. And so we're gonna get our final answer here. X is equal to the natural log of 3 divided by the natural log of 2. Do that on the calculator here. Let's go ahead and do that. All right, so we get 1.5850. Okay. What's that? 5850. Because Stone Cold Chip said so. Yeah! Give me my two coffees slammed together. Yeah, get that the caffeine, man. Blah, 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 blah. That's what I got. I got one coffee right here. Blake, I got one coffee right here. Thanks for the hydrate, Blake. Thank you for the hydrate, Jess. I appreciate that. Oh my goodness. 2,000 channel points to Stone Cold 2 cups of coffee. I get like the I get like the double shot Starbucks cans you get at the gas station. You just slam them together and start chugging it down. Thank you, Khadija, for the hydrate. Khadija wants to hydrate again. Yes, I can do that, Gomesh. That's not a problem. Oh man. Alright, you just gonna keep hydrating me with food. Alright. Thank you very much. Alright. Any questions about that last example? Good lord. The stream never gets boring. That's the nicest part. The stream never gets boring. You gotta finish it now. Yes, Chips! I'm buzzing right now. Yes, Yusuf! Yes, Yusuf. I hope you're doing fantastic, my friend. Yes, you gotta be buzzing, my dude. You gotta be buzzing. 100%. Alright? Because England had won a very well played match, 2-0. You can't argue with that. What is this? What is this? All this hydration, man? I'm taking small sips here, so. Alright, good stuff. Alright, there you go. Yes, indeed. There you go. Alright. We gotta get moving to the next example. I gotta do the next example. Otherwise, I'm not gonna get this done today. I gotta get stuff done. Alright, it's the end of the posture check. Thank you. Thank you. Appreciate it. Alright. Alright, last one for these exponential guys, and then we'll move on to the log guys. Alright. I usually do the hydrates with you, but this is ridiculous, and I'm out of water. You gotta just, take a little sips at a time. No worries. It's fine. Just, you take in moderation. Everything in moderation. Always important. Always in moderation. Okay. So let's go ahead and take a look here at this question. All right. All right. Tell me, you guys, what would I do first here? If I'm going to solve for x, what should I do first? What do you think is a grand strategy here for us to solve for this equation? Move the exponents. I can't move the exponents yet, Khadija. I have to do one thing before I can do that. I agree we have to move the exponents. But before I do that, what do I do first? I'm only allowed to move. There you go. I'm going to take the natural log of both sides. That's correct. All right. So the rule is you have to take the natural log first, right? All right. Natural log, or you can't move exponents, all right? Because I don't have access to the rules unless I do that first. So I agree with what we're going to do next is take that exponent, bring it out. So we're going to have 2x plus 1 times natural log of 7 equals x plus 2 natural log of 3. All right, there we go. Perfectamundo. Okay, now the next thing that we're going to do here is we're going to take this natural log of 7 and this natural log of 3. We're going to distribute it to both terms inside each of these guys. So we're going to distribute here, distribute this natural log of 3 here and here. Okay, that's the plan. So what we're going to have here is we have natural log of 7. We're going to have 2x times natural log of 7. Actually, let's put it this way. Let me rewrite it this way. Maybe this will be a little bit easier to digest. So I'm going to put x in the front, and then I'll put 2 natural log of 7 out here. And then plus natural log of 7 equals x times natural log of 3 plus 2 natural log of 3. Okay. So there we go. I went ahead and distributed each one of those just like so. All right. So far, so good. Okay, now this next part here, I'm going to go ahead and guide you through this next part here because this part here would be a little bit tough to find when you first do it for the first time. So I'll guide you through this one because I do have to actually keep going here. So what I'm going to do here is next I'm going to go ahead and move the natural log of 7 to one side. Again, natural log of 7 here is just a plain Jane number. Again, it doesn't do anything. It's just a decimal. That's fine. I'm going to move the x natural log of 3. I'm going to move that to the other side as well. I'm going to put all the x's on one side. I'm going to put all the numbers on the other side. Okay, so that's what I'm going to effectively do here in this case. All x's on one side, all numbers on the other side. Again, our goal is to solve for x. So go ahead, Blink. What's going on? Why are there 2 natural log of 3's? Because I distributed natural log of 3 to both the x and the 2 here. That's why there are 2 natural log of 3's here. Same thing with natural log of 7. That's why there are 2 natural log of 7's. Because I distributed. Yeah. I have to distribute here, by the way, so I actually don't have a choice in this case. In order for me to make sense of this, I have to go ahead and distribute. All right. The distribution messed up? Yeah. Take a look at that part there very carefully. I did distribute here, so be sure to not forget about that. Anti-distribution. So here what we're going to do is if we're going to solve for x, it's as Hunter says, we're going to go ahead and factor out the x here on the left-hand side. So put that in blue, actually. So we're going to... Can you combine like terms on the right-hand side? No, those are 2 separate numbers. If you want to combine it as decimals, you can. But we're not going to go ahead and actually combine them. We're going to leave them alone. So that 2 natural log of 3 minus natural log of 7, we're just going to leave it alone just like that. When we want to do our final answer on the calculator, you can go ahead and just put it in just like that. You'll be fine. The more important part here is what you do on the left-hand side here when you go ahead and factor out the x. All right? So you want to put the x's before the ln. Now the reason why I put the x before the natural log here, Fritz, is because of the fact that it makes it easier for me to see what it factors to. All right, so if I put the x here in the middle, it usually gets confusing for people when they're trying to do this process. So I put the x in the front, so it's just that much easier for me to go ahead and see what's left over when I factor out the x as part of the process. So I have 2 natural log of 7 minus natural log of 3, if I factor out an x, equals 2 natural log of 3 minus natural log of 7. Then I just divide by this whole expression here. 2 natural log of 7 minus natural log of 3. And I'm just going to put that on both sides. And this is in effect your final answer. This will be your answer for x. Okay. 2 natural log of 3 minus natural log of 7 divided by 2 natural log of 7 minus natural log of 3. If you do enter this into the calculator, you'll need to be careful about putting parentheses in the correct places. So be sure to, I can show that off really quick, actually. Let me showcase that off here. Hang on. So here you have on the top 2. Actually, you could do it as 2 steps here. So 2 natural log of 3 parentheses minus natural log of 7. And then I take that answer, divide it by the quantity. I got to put parentheses around this. 2 natural log of 7, and then minus natural log of 3. Then close those parentheses, and then close those parentheses. And I will get 0.0899, 0.09, I guess. Again, one of the things I would suggest for you to do here, Brian, for this one, because I kind of had to go through this example here a little fast, admittingly, is just go through the steps here about how I did this. Again, took the natural log of both sides, distributed the natural logs, all right? Move the x terms to one side, move the numbers to the other side, just like I would any other algebra problem. Factored out an x, and then divided by whatever I factored out, whatever I got here. Doesn't help that work calls you every 2 seconds. Tell work to stop. Okay, just tell them stop it. Just stop it. I know you can't really tell your work that, but okay. All right, good. All right, any other questions about that? This one here, if you're a little confused, rewatch this one. But I have to do some log examples here, so that's next on the docket here. So. So we can't get a common base off the start. We automatically distribute the natural log. I mean, yeah, you have to take natural log on both sides if you can't get a common base off the start. Correct. That's the only way you're going to actually get it to be able to get rid of those exponents and then do what you need to do. Yeah. All right. Let's do the next one here. Now we got to do logs. All right, so here's the first one we got to do. Let's do it. This is okay. That's log base 6, by the way. Okay, so here we want to go ahead and solve for x in this equation. Now, the trick here, again, is to compress this down into 1 log first. Okay? So, remember, go back to your notes here from your previous rules from yesterday. Okay? What rule are we going to be using here in this instance? We had 3 rules. We either use the product rule, the quotient rule, or the power rule. Which rule should we use here in this instance? The product rule. That is correct. Okay, good. So if we use the product rule here, can anybody tell me what would this left... Don't worry about the 2 here on the right-hand side. We'll come back to that here. But if we use the product rule on the left-hand side here, what is that going to look like if I use the product rule here appropriately? What will that left-hand side look like if I use the product rule? Anybody tell me here? What will the left-hand side look? Okay. The library sort says log base b of x plus 5 times x. So this is a log base 6, by the way, not b. This is the number 6, sorry. Yeah, that's a 6. That's my fault. I know it looks like a b. That's cool. It ain't your fault. No. No, Brian. No. We're not substituting 2 for x. Doing nothing of the sort. We're just using the product rule here, okay? Yeah, that's the whole equation here. So we got log base 6 of x plus 5 times x, if we're doing the product rule here, is equal to 2, all right? That's how we can compress it down. Now, if we simplify this out here, we're going to get log base 6 of x squared plus 5x, all right? So I'm just going to go ahead and distribute the x here in this case for a very particular reason, all right? 2 is definitely part of this equation. In fact, it's one of the most important parts of the equation here. Okay. Now, so we use the product rule here to compress it down. Now, the next part that we have to do here in these particular equations, that in some cases, not every case, but some cases, is we need to use that translation that we had discussed here before. So we want to translate this over to an exponential kind of equation, okay? Because we found out previously that if we, translate from log to exponential, it's a lot easier to go ahead and solve for stuff from that point, as opposed to just dealing with logs outright. So in this instance, if we're going to do this as an exponential equation, doing that translation, what we're going to get here is we're going to get x squared plus 5x, the left-hand side here, equals 6, which is the base of the log, squared, which is this 2 that we have here. Okay, so x squared plus 5x is equal to 6 squared. So that's using the translation here. Yep. What's up, Yosin? How you doing, my friend? Okay. So the next part here is x squared plus 5x equals minus 36, or 36, sorry. Getting ahead of myself. And now we want to go ahead and solve for x in this particular equation. Okay. So we're going to subtract 36 on both sides. I'll put this over here on the right. So we get x squared plus 5x minus 36 equals 0. And now we just want to go ahead and factor this out and see what works. Two numbers that multiply to minus 36 and add up to positive 5. That's going to be x plus 9 and x minus 4. Okay, so based on what we see here specifically, we have two answers here for x. X is going to equal minus 9, and x is equal to positive 4. Again, we set both of these equal to 0 and solve for those subsequent x values. All right, now that's all well and good. All right, so that's fine. Okay. Now, this is the other important part here that I'm going to add to the notes here. Okay, so I will be adding something here to the notes for after this example here specifically. Now, we did get two answers here by doing the process. Everything is just perfectly fine in terms of the things that we used. Everything is 100% above board, except for one thing, and that is the actual answer that we got here. Now, let's take a look here specifically at negative 9. Negative 9 is not a friendly solution. Now you're probably saying, well, why is that? Well, negative 9 does not work in the original equation. Remember, if you take the log of a negative number, that's not possible to actually take a log of a negative number. When we first discussed the characteristics of logs, the domain is from 0 to infinity. So it can't be a negative number. That's definitely a no-go there. So what happens in this case? Why is that bad? Well, that means that essentially we're going to throw away -9. But -9 also has a different representation in mathematics. We do actually have a name for this here. So if they ask you this on the homework, then you'll know exactly what they're referring to. This is what we call an extraneous solution. All right. So this is what they call an extraneous solution. Now, to be pretty crystal clear here about an extraneous solution, let's go back to the notes here for just a moment. All right. So an extraneous solution here. Oops. Scroll over there. So an extraneous solution is a solution that is found that does not work in the original problem, original equation, whatever you want to call it. All right, so that is an extraneous solution here. So it's a solution you find, but it doesn't work in the original problem whatsoever. So it's an answer that we effectively throw away. But if they do ask you on the homework, says, hey, what's an extraneous solution? Then you know exactly what it's referring to here. -9 is an extraneous solution here. Now, if you try 4, 4 would definitely work in this case. 4 is just fine. But -9, that's a no-go here. So your actual final answer here, if you look at it from just a singular point of view here, is going to be +4. That's your guy there. We're not dealing with imaginary bases here, Hunter. That makes no. No. Now you're just being a troll. Now you gotta stop. All right. Sorry. Okay, fair enough. All right. How can I say no to you? All right. So, yes, so x is equal to 4 here is going to be our final answer for this problem. All right. All right, that's fine. Any questions about that so far? Any questions? Yeah, sure. Oh, hang on a second, Fritz. Let me make that a bit bigger. There you go. That should be easier now. Sorry about that, my dude. Nope. Hey, Jess, did you figure out your calculator issue? I hope you did. So, just let me know if you did figure out your calculator issue there. All right. All right. Okay, next. All right, next problem here that I have to do, like a required problem. Oh, I don't know what's the matter? Okay. We can take a look at that after class if you like, Jess. Oh. a second. Where'd that go? I saw this question a second ago. Alright. Hang on a second, guys. I lost my problem there. Okay, yeah, okay, that's the problem I wanted. Okay, I just mixed up the two there. Alright. There's a very specific problem I want to do. There's actually two specific problems I want to do, so both have very important implications, so I want to be sure that you guys get a good look at these. Yeah. Okay, so this is the first one here I would like to do here. I want to give you, again, different looks here at different types of problems. So we get log of 5x plus 1 is equal to log of 2x plus 3 plus log of 2. Okay, now in this instance, we're going to do, again, as you can see here, we have a log of 2x plus 3 and log of 2. Now, in that case, we're going to go ahead and use the product rule on that, and we're going to go ahead and combine those together into one log. So here we have log of 2x plus 3 times the 2. And we still have the log of 5x plus 1 on the left-hand side. So cleaning this up a bit, we have log of 4x plus 6. And we have log of 5x plus 1 on the left-hand side. Now, the reason why I wanted to showcase this one off here is simply because I wanted to show off number 2 on the handout here, as you can see here over on the right. What is the one-to-one property for logarithms? So much the same way we had for exponents, we can also do the same thing for logarithms. If we have log base b of something equal to log base b of something else, well, we can just basically like cancel out the logs, if you want to call it that way, and set both of those guys equal to each other, the m and the n. So we could just basically, again, if you want to do it as easy as possible, most people just go ahead and just cross out the logs here. If you want to do that, that's certainly possible underneath this one-to-one property. And then you could go ahead and proceed to do the problem like a regular algebra problem. Right, so in terms of how straightforward this is just fine. So let's go ahead and solve for x here. As we get down to this point, it's really not too hard. We'll subtract 1 here as well. So here we get x on the left-hand side. 6 minus 1 is 5. And so x is equal to 5. And there you go. You got yourself a winner. Okay. So I just want to showcase that one off here. Again, that's an important problem just to use that simple one-to-one property for logs, and it works exactly the same. Again, what we did for exponents, it works pretty much exactly the same here for logs. As long as they're both the same log base, you should be good to go. If you have different log bases, well, that's a completely different story, but we're not going to run into those type of problems here, okay? So don't worry about it, all right? So we're not going to be running into any of those type of problems. That is there's something much more advanced. All right, so that's not within the scope of this class. Now, the next one, I do want to show off the next one here. There's a couple of, again, I have a couple of very specific examples that I do want to showcase here to let you know about it. So quickly do the next one here. Let me write that one down. Okay. Okay. So this is what we have here. We have log of 3x plus 3 is equal to log of x plus 1 plus log of 4. Okay, so let's see what we get here for this one. solving for x. All right, so can anybody tell me here, what do we do first? What do we do first in this problem? Product rule. Okay, good. That's correct. Got to do that product rule. We have log of x plus 1 times 4, right? On the left-hand side, that doesn't change. We haven't done anything with that, so whatever. All right. So, on the right-hand side here, we have log of 4x plus 4. No question about that. We're just distributing the 4. On the left-hand side, we have log of 3x plus 3. 3x minus 3, sorry. Okay, there we go. Okay, fair enough. Okay, what's next? Okay, logs cancel out, solve for x. Okay, that's fair. Alright, seems fair to me. That 3x minus 3 is equal to 4x plus 4. 100%, I agree with everyone here. Let's solve for x. Anybody have a final answer here for x, by the way? I'm just going to go ahead and do this methodically here. -7, okay, good. That's correct. 7 here. So, do this out. X is equal to -7. All right. X is equal to -7. And, all right, good stuff. So we found a value for x. Great. Good job. But there's a but to this. Uh-oh. -7. Algebraically, it's correct. It's negative. What's the catch? Yeah, there's a catch. What's the catch with this, everybody? What's wrong with -7? Football's coming home, that's correct. England are back, baby. England are back. No more bottle jobs. Plus or -7, I wish. I wish, Fritz. No, no, no. Ah, it's an extraneous solution. That is correct. That is correct. It is an extraneous solution. If you try and put -7 into the original function, you're going to have a negative log. And that's not something you want. Right? So, this is an extraneous. So it's not even a real solution, it's an extraneous solution. It doesn't work in the actual real problem. So your actual final answer here, the way you want to kind of express it, you can't put down -7 because that's not your actual final answer. Your final answer here is no solution. Now, to point this out here, and the reason why I wanted specifically to do this problem was because of this fact. There's no solution here, but it's also listed as the thing. FootChamp, you could go ahead and ask any question you like. They put a big circle and a line through it. So if you see a big circle and a line through it, that also reflects no solution. Okay, so it's like the empty set. So no solution or a big circle with a line through it, that also reflects no solution. So that's another piece of notation there that will reflect exactly that. Is football coming home? You're damn right it is. You're damn right it is. Of course, football's coming home. Hey, FootChamp, have a pint for me today, okay? Have a pint for me tonight. Go out and enjoy yourself, alright? Football's coming home. No more bottle jobs, guys. No more English bottle jobs, okay? No more bottle jobs. All right? No more bottle jobs. This is the year for England to win. No more bottle jobs. This isn't the World Cup, okay? This isn't like previous international competitions. No. This is the real deal this time. Raheem Sterling, my man. My man, Raheem Sterling. Bottle job just means you messed it up. That's all that means in British English. Nice there, Retta. Too funny. All right. Things with a things with pears shaved in it. Oh Lord, you guys. All right, let's do. I could do one more here. Let's do one more example here for some. You can't hate a country. That's not good. Belgium are without Kevin De Bruyne and Hazard. Is Hazard out? So Italy will beat them. Is Hazard out? I know he got injured last match, but I didn't know he was out for the next one. I know De Bruyne's injured, but I didn't know Hazard was injured after that last match. Like he pulled, I remember he pulled up with his hammy late into the contest. So rest of the tournament. Oh, yeah, that's gonna be a big blow. Don't underestimate Belgium though. They're a deep team, a very deep team. Never underestimate Belgium. They are a very stacked team. People sleep on them. They're not pushovers. They have a lot of depth. Sure, you can't replace De Bruyne or Eden Hazard, but you know what? You still have so many good players on that team that absolutely can destroy you. It's not something to look down on. But it's coming home. It's coming home, Foot Champ. That's true. So are the amount of pounds that you're gonna make off the bet. That's gonna come home. I promise you that. You ain't wrong. God save the Queen. Bruv, you need to get some more pints in you tonight. That's what you need. Everybody's in on it today. Okay, next one here. Log base 2 of x minus 1 minus log base 2 of x plus 3 is equal to log base 2 of 1 over x. Okay. So, tell me what I need to do here first. What do I need to do here first? 27 to 1 odds. That's really good, actually. You get 27 to 1 odds? That's easy, man. It's 2,700 pounds. Quotient rule, that's correct. 2,700 pounds, my dude. That's what you're aiming for. Alright, so quotient rule here, let's go ahead and take a look here. Log base 2 of x minus 1 over x plus 3 equals log base 2 of 1 over x. Alright, what's next? Yes, sir, 2,700 pounds. Bases cancel out, 100%. All right, that's fair. Okay, here in this case, you'll donate me 50p. You're so cheap. Foot champ. Only 50p, bro. Alright, we're gonna go ahead and cross the multiply here. Multiply by x here on both sides. Oh my gosh. We can also cross get x plus 3 times 1 equals x times x minus. Hey, Gemma. Welcome back. Maybe a pound if you blow me a kiss right now. I'll allow that. Only a pound? My dude, you're gonna need more than that. You'd be like mwah. Good job. Now I get a pound, oh boy. I need a fiver for that, my friend. Alright. I need a fiver, my dude. X plus 3 is equal to x squared minus x. Alright. So that's what I have here once I go ahead and distribute the x here to both of those sides. Now again, what I want to do here is move everything over to one side, and we're going to go ahead and solve for x. Let's move everything over to one side. We'll factor, and go ahead and solve for x. Of 0 on the left-hand side, of x squared minus 2x minus 3 on the right-hand side. Factoring this out, we're going to have x minus 3, x plus 1. Okay, so two numbers that multiply to minus 3 and add up to minus 2. Now, why would I say that? That's not nice. I happen to like German people. They're very nice. Look, England beat Germany. It's over. It's done. You guys, we won, okay? No need to rub it in. Don't time him out. He's a nice guy. He's a nice guy. Don't time him out. It's fine. It's 100 pounds. Well, that's fine. I know it's 100 pounds. But don't stake your whole future on the 100 pounds, by the way. So. Alright, so we get two answers here for x. X is equal to 3 and x is equal to minus 1. Alright, so which answer should we get rid of? Which answer would be extraneous according to what we have here? What answer would be extraneous? Would it be 3 or would it be minus 1? Minus 1. Okay, good. That's correct. So minus 1 is out. That's an extraneous solution. So our only solution that we have here would be 3 as a result. And that's our final answer for that. Very good. Very good. Any questions about section 4.4? We did a lot of different examples here, so hopefully you got a good look at everything about what we had covered here. That's the end of 4.4 here, but we'll be doing 4.5 here tomorrow, which is the end of Chapter 4. So later on this week, I'll be making up a test. I'll be making up the test here for Chapter 4. So Chapter 4 test will be posted this week, but we're not done with Chapter 4 just yet. We have one more section to go with that, and then once we're finished with that, there you go. Then we'll be moving on to Chapter 5 and moving our way up on our way forward. That's what we're doing. Oh my goodness. Okay, I got to sing everything. Very good. Okay. All right. So that's what's on the agenda here for tomorrow, is getting that stuff done. Of course, last section of Chapter 4, and then we're gonna go ahead. Last section of section 4.5, excuse me, and then we'll move on here to Chapter 5 right after that. All right. Everybody good with that? And remember, as Foot Champ has said, football's coming home. God save the Queen. 100%. Congratulations to England on a 2-0 victory over Germany today. Let's see what happens in the round of 8, ladies and gentlemen. Let's see if Foot Champ can turn that 100 pounds into 2,700 pounds. And hopefully buy himself something nice. Crazy to think the first month of class is always almost over. It's true. First month of class is 2 days from being over. Thank you. I also got here late start when you were talking about traveling. If you ever get the opportunity, I would love to go to South Africa. That would be really nice. My mom and my sister have been there. Went on a safari adventure together. I couldn't go with them because I work a lot. So, but yeah, would love to go sometimes. Yeah, it's just 4.4. We're out of time, my dude. Brian, we are out of time. We have gone the requisite 2 hours. That is that's what we've done. Oh, the approximate 2 hours here. Goldmash to ask a question? Okay, go ahead, Goldmash. If you want to ask a question, no problem. As long as it's a good question, hopefully. Just for homework purposes? Right on, right on. It was good that you're keeping up there, Brian. Good that you're keeping up. Anybody have any more questions or anything they would like to say here today for the end of class? Who will win, Sweden or Ukraine? I think it will be... Ah, man, that's a tough one. Sweden is okay. Like they're not like the greatest team, but you could say I could probably go with Sweden over Ukraine by like a 1-0 scoreline. I think that would be fair. Like 1-0, Sweden over Ukraine. I mean, it's not as crazy as the Spain-Croatia match. That was pretty nuts. Jess, I'm gonna be on Discord there. I'm gonna help you out with your calculator on there if you like, okay? So I don't have a problem with helping you out on that. So. All right. Well, ladies and gentlemen, this has been a pretty lively stream here today. I ain't gonna lie. It's probably one of the most liveliest streams I've had this summer, and I'm very happy to be a part of it. Most definitely. All of you bring such a wonderful energy to the stream here. I really appreciate all the time and energy, and the fun times we have here during even in a subject like mathematics. 100%. I want to thank I'll thank everybody here. I want to thank everybody here again. Hunter, thank you so much. All you guys, Jess, Khadija, Brian, Lysa, Rena, Fritz, Foot Champ, Goldmash. All of you, absolutely fantastic, absolutely fantastic. Gemma came by here. Thank you very much. Yosin came by. Thanks very much, Yosin. If I'm forgetting anybody, then I apologize. Nicholas, I know I'm forgetting Nicholas. You guys are absolutely fantastic. Thank you so very much here for a great day here today. As always, we're gonna be back here tomorrow, same time, same place. Hopefully, same energy, because today was a lot of fun. A lot of fun. So thank you all very much. You all are super duper kind. All right, 1000% super kind. All right. Okay. So we will see you tomorrow, same time, same place. And as always, ladies and gentlemen, remember, stay safe, stay healthy, but of course, most importantly, stay sane. All right. Have yourself a wonderful afternoon/evening to you. Jess, I will see you on Discord here, so make sure you log on to Discord. And everybody take it easy. I'll be on Discord, by the way, should you need to ask any more questions. All right, and we will all see you later. Have a wonderful afternoon, everybody. Take care of yourselves. Have a great one. All right. Bye. See you guys. Thanks, Yosen.